and then upload it later. Okay, cool. So we are live. And thank you for joining, Mark and Matt. It's a fun time to chat about vanilla extract. So do quick rounds of introduction, I guess, and dive in. So I'm Kyle Matthews, founder of Gatsby.
I'm Mark Douglas, co-creator of CSS modules, now co-creator of vanilla extract as well.
Matt Jones, Matt Compiles on Twitter, and co-creator of vanilla extract and Tree.
A lot of CSS power in this virtual room. Yeah, so I saw Mark's announcement, like a lot of you did, on Twitter about vanilla extract. It looks super cool. I played around with it a decent bit, built a little Gatsby plugin for it and so forth. Yeah, and I was just curious to kind of hear more about the story of how it came to be, because Mark, you're really well known, of course, CSS modules. I was actually looking up the history before this call of CSS modules, and the first commit to sort of the spec repo was like within a week of the first commit to Gatsby in May 2015. So almost 6 years old. Feels like we've gotten old together or something like that. It's just a beautiful nostalgic thing. Anyways, yeah, so like CSS modules, been a huge deal, tons and tons of adoption. Yeah, and CSS and JS and it's also got lots of adoption in sort of the React and greater JavaScript community. And so now there's this new thing, vanilla extract. So yeah, maybe just sort of walk through the whole history of sort of evolution through here, and why vanilla extract? Why now?
Yeah, so the biggest thing to call out with vanilla extract is that it's the culmination of a lot of work over many years. And if you trace it back, it all sort of each step kind of made sense to us along the way. So obviously CSS modules is the big one that we're known for in terms of the work we've been doing. If I go back even further than that in terms of where CSS modules came from, we were relatively early to React and moving towards server rendering with React. That was a big thing for us because we wanted to have the rich UI, but also the SEO just baked in. All of that was so attractive with React. And we were building up a component system, and the CSS ecosystem in React was obviously very underdeveloped compared to now. And we were basically writing less style sheets and running them through Webpack. Less was a decision that predated me at Seek as well. And we were just doing like hand-rolled scoping with BEM. Like, for those who don't know, block element modifier, it's just like a naming convention in the global scope, right? And so you just basically prefix every, you just prefix every class with the name of the component, right? And so we just did that like religiously. Every single component had a matching less file with the same name, and every class in it was prefixed with that name. And so we went all in on that, and that was working really well. And if you think about it architecturally, that is basically CSS modules, right? Like just done by hand. And so what happened was like Webpack introduced this experimental feature of local opt-in local scoping. It had this weird syntax. I forget what it was. It was like it changed as well a couple of times, one or two times. You'd put like local and like brackets around the class that you wanted to scope. And so as soon as I saw that, I was like, oh, well, that's pretty awesome. Like, because that's kind of what the way we think about it already. And so we went through and I went through in like an hour and like just like manually just like converted every class into this local scope syntax. And then that's when basically CSS modules were staring me in the face, because I'm like, well, hang on, like there's like a couple of exceptions in the code base where I don't want it to be local. Like, shouldn't this syntax be the other way around? And I created a post CSS plugin to do exactly that, and I call it post CSS local scope. And the notes on that was basically like, you have to be using Webpack, you have to have this feature, but it will like convert all your styles into like a local scoped styles. And it was one of those things where it just felt so right then, because it was like, well, now every time I just open a style sheet, start writing classes, and the scoping is just for free. And if I need global scope, I can explicitly say it's global. And one thing led to another, where like Tobias Coppers, who works on who created Webpack, reached out. He was interested in what we were doing and wanted to make it official. We bounced around some ideas and extended the API a bit further as well. And I was the one who was kind of pushing for like, I feel like this thing needs a brand. it needs its own identity. It can't just be like a weird Webpack feature or something. Like it needs to be its own thing.
Yeah.
And that led to CSS modules getting a name and a logo and a repo and a sort of a thrown together spec and all that. And before you knew it, it was a thing and it was big. And it's to this day, I'm still surprised how far the reach of it is. Like I keep seeing new build tools come out, and they're like in their bullet list of features, they're like, oh, and we have CSS module support. And I'm like, oh yeah, that's so cool that it's just become one of those things that's just, you have to have it. It's not even like an official standard or anything in that sense, but it's in every tool. So that I'm still very humbled by that. Like it started with it was just like a little post CSS hack that's snowballed. Like it's pretty cool to see. But because we were so early, right, we're effectively on our own separate journey to the industry, where we were building up component libraries on top of CSS modules and scaling them out through the whole company, and using less. Like less was our go-to still for years after that point. And separate to all that, CSS and JS kept going, and all this new innovation all the time, new rounds of libraries coming through constantly. And I was always a fan of that stuff. We didn't adopt it ourselves, but I was always a fan of it. I think what happened was, maybe to jump forward a few steps in the story, we wanted to replace less with something. And I actually found a Webpack loader that let you effectively just use JavaScript as a preprocessor. It was called CSS in JS loader. And it let you write like a JavaScript file that would export a JSON blob of like what looks like a style sheet, just written in a JSON format. And that would then create a style sheet. And when you inputted it on the other side, it basically felt like CSS modules, but you were using JavaScript as your preprocessor instead of Sass or less. And that was pretty cool. But what broke that model was introducing TypeScript. We moved to TypeScript. And that model just does not work with TypeScript, because you're exporting one thing and importing a different thing on the other side, because there's Webpack magic like in between this file, like what's being exported and what you're using. And we also, I won't go into too much detail on this one, but there's also the theming issue. We wanted to build a themed design system, and there wasn't a good way for us to do without CSS variables at the time, and there wasn't a good way for us to do theming. So that's what led us to, maybe Matt could talk from here, because it was his baby at this point, seeing this sort of awkward position we were in with trying to get it type safe.
Yeah, so we're in this crazy world where we were doing theming manually. We were creating a different set of CSS for everything. And on day one in Braid, which is our design system, we had maybe like three themes, I think, maybe four. And so there was this like manual overhead of like recreate the file, and it was a nightmare. At the same time, we really went full on into TypeScript, and we converted all of Braid to TypeScript. And then it was even harder again, because we're trying to get these types to flow through, because the problem was that there's no good type safe boundary between the style sheet and the actual application code. But that application code was part of, it was like they sort of coexisted. And so that's where the idea of Treat, which is our sort of precursor to vanilla like library, which is, still going in its own right. And we wrote that, and then that's what Braid got written, and is running into today. Like we haven't even launched vanilla within Braid yet. The thing that's different about Treat and vanilla, Treats, they're very similar in concept. They both have this idea of processing JavaScript at build time. They both have this idea of having a type safe bridge between your build time style code and your runtime JavaScript code. The difference though is mostly in the theming, in that Treat was born in the days of, we couldn't use CSS variables. They were around, but we definitely had to support IE11. It just wasn't an option to use CSS variables. And so the way Treat did theming was sort of our own little concoction of how this would work. And what it would do is it would, for every class that was themed, which would be your classic, your theme comes in as a function. So you sort of say, you get past the theme and then you create a style block based off of that closure, I guess. We would actually create a different class, and there'd be a different class for every theme. And then we would hot swap that at runtime. So basically like you would still have a static style sheet, but the themes were encoded into the class names, and it would know which class name to apply at runtime. So you could still have static extraction. You could still only send down the themes that you wanted to send. So if you only wanted to send down one theme to a particular app, you could do that. The problems though, you couldn't bundle split in other ways though, which is one of the big limitations. So you couldn't route split your CSS because you were already theme splitting your CSS. Like route splitting gets more complicated the more ways you want to cut it. And so, yeah, that was one of the big limitations. It also was very complicated to be able to generate CSS in that way because the themes were like this global concept. Like you could only have one concept of a theme, and then you could have different implementations of it, but it could only be one. Like you couldn't have a library over here that has a whole different set of themes. Like they were in like this global scope. And so that was kind of the limitations of that model. And then so that led into today, where our browser support policy hit a certain point where we were allowed to drop IE11, and the other browsers that didn't support CSS variables. Hopefully most people are getting there now. And then so we basically did an experiment on treat. So like, what would treat look like if we replaced the theming model with CSS variables? And then vanilla was born. So really it started off as treat major version 3, but then we realized it was just so different, and we wanted to fix a lot of the problems that we had with treat. And so we just made a whole new thing. I don't know if you want to jump into like vanilla stuff, Mark. Or...
What's like kind of the timing for this? Like, when did you start working on treat, and when did you start working on vanilla extract?
Yeah, treat. I've been guessing a little bit. It's probably about 2.5 years ago we made treat and launched it. We worked on treat. Treat was quite difficult because it was one of the major differences between treat and vanilla is treat's technically more difficult to achieve because of its theming model, and therefore it was very hard coded to Webpack. It was very Webpack exclusive because it had a lot of plugin code, which is like took me a long time to be able to actually get working. Because there's not really once you're that deep in Webpack land, there's no one outside of about 10 people on the planet. There's not many people who can help you. So that took about 3 to 4 months to really get treat going to be production ready. And then we launched it in Braid. We've been using it for like 2 years, maybe a little more. And we use that both in Braid and the rest of our company, which is Seek. It's a job board in Australia. And a few other countries. And then, so then vanilla was sort of born, 2 months ago now, I guess we started work on it.
One thing that it's probably obvious from what you're saying, but like the complexity inherent in treat was one of the big motivating factors for us to revisit it, because it just felt like it was sort of, it made it harder to maintain, but it also meant that we felt like we were very much coupled to our current build tooling. And that's, we're in an interesting spot right now with build tooling where there's clearly like changes in the air a little bit. Like there's new things coming out all the time, and people, ES build's the big one that's getting a lot of attention at the moment. And, that definitely factored in as well. Like us looking at that and saying, we could work to because we kind of had a couple of options there, right? And Webpack 5's persistent caching was another one where treat's model just did not play well with that. And so we were sort of faced with this decision of like, okay, do we try and port what we built over to these new systems, or try and make it fit in with Webpack's new caching model? But it seemed like, given the change in browser support policy, the simpler choice was just to revisit the way theming works and get rid of all the bundler magic and just do it as natively as possible. And I think the proof of that came through in how quickly we were able to build vanilla extract. Like compared to treat took a lot of, we did borrow a lot of code from treat in vanilla, but even so, like we managed to get it working very quickly and then ported to other bundlers very quickly. Like Matt wrote an ES build plugin for it already.
Wow.
I've been
working for an alpha project.
And I've been working on a roll-up version as well, which is awesome. It's not out yet, but it's not far off. Like it's pretty straightforward, and we feel very confident with the model that we have that if a new bundler came out tomorrow, we could support it pretty quick. Like it's a really nice, simple, in a good way, like simple model we have, I think.
And when you get that sort of portability and simplicity, it's like not all things should be simple. There are very complicated things that are still right, but all the things being equal, if you can dramatically drop down the simplicity and still do everything you want, that's a really good feeling, and you're onto something. Well, cool. Maybe we'll just jump to a demo and see how it works.
Sure. I'm going to share my screen. That's us.
Yeah.
You can edit that bit out.
Yeah. Probably won't, but.
No? Okay. So this is Vanilla Extract's README. It's very exciting. We actually don't have a doc site yet. That's how early it is. That's in the works.
Gatsby didn't have a doc site for like 2 years, which I thought was really funny for a website tool.
Yeah, well, if you want to say you were using this before it was cool, now's the time. So
okay.
you can see how early it is. I'm just going to read you the bullet list here. So yeah, all styles generate at build time, just like Sass. That's the key thing. Like conceptually, you think of it like a preprocessor effectively, but with a lot more features than that. But in terms of the runtime characteristics of it and the way you architect your code, it's closer to that. This was an explicit goal compared to Treat. Our earlier work with Treat is that, particularly around the theming, is we're trying to make it have the fewest opinions possible in a good way. Like we don't want it to be so low level it's a pain, but we're trying to leverage the platform as much as possible. Yeah, so it has a locally scoped class names. I skipped one there, which is a big one. It works with anything. Like it's just like any CSS preprocessor type model, like it works with anything. You get the local scoping of classes like CSS modules, but we also locally scope CSS variables, which is a big one for us now, and also keyframes, font face. Anything that introduces something in the global CSS scope, we hash that for you. It's got theming system. We have utils for generating calc expressions. We found that was a bit of a pain migrating from like styling is just JavaScript to like you have to think about the runtime of CSS of variables and calculations based on those variables. You have to start writing calc expressions, which we didn't write before. And so we've also provided a utility to make that a bit more straightforward. This is one thing that Matt was always wanting to do with Treat, and sort of never, like I don't think it was really possible with Treat's model. Like, now we have an optional runtime version for. It's not designed for production, to be clear. I mean, theoretically, you could run it in production, but we wouldn't recommend
People have
it
done
at all.
worse, so
Yeah, it's sort of like if you're running it in production at that point, it's almost like
why? If you want the overhead of styled components, then just use the.
It's probably equivalent to style components v1 or something.
Yeah.
So where this is cool for us compared to Treat is like now in our tests we're actually generating styles, whereas we weren't previously. So that's pretty cool. And we also provide some APIs for dynamic runtime theming, which is really just some light sugar over the native APIs for setting variables on elements, right? So it's very lightweight, but it means you get the type safety of like you can pass in an entire theme and set that whole theme on an element imperatively if you want. So you do, so there is still runtime aspects of it that the platform can do. This is the basic like CSS TS file. So that's the trick. I mean, we sort of called it out a little bit, but you still have, just like working with CSS modules, you've got your separate CSS file, but it's in TypeScript here. You have to import the APIs you want to use from Vanilla Extract /CSS. Here we're creating a theme and we're using that theme in a style. So what's cool is like when you create a theme, you can pass in a deeply nested object of all your tokens that you want. And it's going to, in this API is going to return you a theme class that you can put in the document. And then this one's going to give you your variables and you can use those. I'm just going to do a quick skim of like the main points, and then I'll jump into a live demo. So in terms of setup, like we've got Webpack support, which we need for our work. But then, as I was saying, Matt's got ES Build working, which is pretty cool. Gatsby support, thanks to you, Kyle. Thanks for your early adopter support. And so then in terms of style, like we're not going to use all these features today, but just to make sure people understand it's not limited in any way. Like you have basically the full power of CSS here. Like you've got your normal styles. You can set CSS variables. You can do simple pseudos at the top level, like hover and focus and that sort of thing. You've got selectors where that's where you would do more complex pseudos if you need to, like hover, not focus or whatever. You can do all that here. Nth child, 2n, whatever, you can do that here. You can reference other classes as well. That's down here. Like your selectors can reference other scoped classes. You can have media queries, feature queries. They can all be nested infinitely, just like in the native CSS. There is support for global styles if you need them, resets or whatever, things like that. Yeah, there's a bunch of APIs around theming. Lots of options there around whether you want to have. It all depends on what you're doing for theming, and we wanted to make sure we support all the different styles of theming really well, because there's probably the most common. I did a Twitter poll. The most common is you just have one theme for your whole app, and it's basically global, and you just chuck it on root, and that's fine. That's the most common. But we also support.
I think for most people, they just want to have something to reference. You know,
it's just about the variables. That's it.
And
so we make that nice and easy. We have a create global theme, and you just point it at a selector, and you just go put these variables on root, and then it just works. You just have your variables come out. But we also support this. Like, what I like about this is we get the best of both worlds with our APIs, where in our case, we're going pretty far with theming, where we have like lots of different themes, and they're all completely independent from each other, in that an end user is only supposed to get one theme. So we need to be able to bundle split those themes out, but we still want it to be type safe. And so that's where this sort of APIs are really cool, where you can like create your theme bars up front it's basically just like creating the contract that you want to implement. So here's my theme A. Obviously it's just placeholder naming. I've got theme A and theme B, and they create a theme based on this var contract I've defined here. And so obviously at the moment, this is all in one file, but in a real, if this was what you're trying to achieve in your project, what you can do then is you would put your theme contract in one file, and you'd put these separate themes in their own files, and you could bundle split those. And so, and you could load them dynamically or whatever. So as an end user, I only load the theme that I actually need. So it's cool that we can go all the way from basic global, like root style themes, all the way to like bundle splitting, a white labeled app for different users. Like it can go all the way from that range.
And this is the power of JavaScript, that you can do more complex constructs like this without much fuss. It's just code,
especially with TypeScript. It's cool that you get that type safety where like if I forget one of my variables here, it'll tell me. It'll be like, you haven't set a brand color.
I feel like this is an interesting point, right? Like in that, one of the major motivation really is for building CSS this way is that we find CSS is not that scalable. In a huge app, especially when you have a design system with 40 dependent apps, which we have at Seek. This allows us to like basically have all the scaling tools we've built into JavaScript and TypeScript for the last like however long, and actually have them in our CSS, but without really losing anything that CSS gives us.
Because like JavaScript code bases, TypeScript code bases get into millions of lines, and most CSS is hundreds, thousands, and then I don't know. It just isn't a programming language in the same way, so it just doesn't have the modules and namespaces and other stuff that allow for easy scaling. Variables is anyways. It's just tough because like browsers change so slowly. So maybe if it was like somebody's SDK or something, then they could just like lickety split out all that stuff. But given the constraints that we have, it's probably the best we're going to do.
So I don't want to dwell on the README for too long, but wanted to give an overview of sort of like you can do all that sort of styling and global styling if you need it, and you've got a bunch of APIs for dealing with theming. This is a basic, very beautiful app that I've thrown together here. So this is running in Webpack. I've got my app component here, and it's rendering a banner. It says, "Welcome to Vanilla Extract." If I go into my banner component, you'll see that it's just a basic React component. It's accepting children here. I'm rendering a div because I'm a React developer. Everything has to be a div. I've got a class name with styles.banner. So at this point, it looks very much like CSS modules, right? Like I'm importing star as styles from banner. It even says banner.css. It's a little bit of a sleight of hand here because TypeScript doesn't like you to put .ts at the end of your imports. So it's actually banner.css.ts is the file. So if I jump through to this one, you'll see that it's a TypeScript file, and I'm importing style from vanilla extract /CSS. I'm exporting const banner, and it's a style with some, some very nice looking styles. So yeah, like I said, you get the ergonomics of CSS modules in terms of the way the imports work, and you've got your styles object. I mean, you can name that whatever you want. Like at the moment, I've called it, what do I call it, banner. I can do a named import if I want, and that will work. But we find that this sort of scales awkwardly because especially because you start to get name clashes between like your props and your styles and stuff. So it's kind of nice to just put it in but it's up to you, right?
Yeah, the first little site I built with this, yeah, I had the same thing. I was like doing named or the destructuring, but yeah, styles is much easier.
Yeah. So what I want to do is show you, like, this is obviously quite a contrived demo at the moment where it's just one set of hard-coded styles. Before I go too far, what I will do is show you like the runtime, or like what's sort of coming out the other end, right? So here I'm getting like a nice readable class name in dev, like banner underscore, it's a bit small there. Banner underscore banner, like it's the file name and the class name, they're the same. That's why it's the duplication. And then there's a hash. So in production, just like CSS modules in production, you just get the hash, which is cool. So if I like view page source on this and I see there's a main CSS at the top, right? And I click through to that, like I've got a static CSS file coming out the other end of this, which is cool. So what I'm going to do is try and make it a little bit more realistic in the sense that, like, as a React component, I probably want something dynamic happening here, even though it's a static style sheet. I want to be swapping out different things. So what I'm going to do is this combination of background and foreground color, I'm going to pull that out into, I'm just going to call it variants, export const variants. And we also have this API called map to styles. And what it's kind of designed for this use case, more or less, which is like, I want to create an object like lookup of sets of styles. So I'm going to create one here. I'll call it primary. I can call this whatever I want. I'm going to call it primary. And the idea is that so obviously my styles have now vanished. I've got my primary here and I've got background and foreground color here. While I'm here, I'm going to make a secondary. Just to prove the point, and we'll say background here. I'll say it's aqua and the foreground color is blue. Okay, so my styles have vanished from the core set of the banner one, right? So what I want to be able to do now is wire up that map of styles into this component. So I'm going to add a new prop here called variant, and I'll make it optional. And it's going to be, so this is a pattern we find is quite interesting, is I can use the style sheet as the source of truth for what my prop is here if I want. So I can say that the variant prop is driven off key of type of styles dot variants. And so now the type of variant is, you'll see there, primary or secondary. It's just driven off the style sheet. Even though it's static CSS, right? I'm using it as the source of truth for my types. And so now, yeah, so down here, I can pull in my variant. It's optional, so I'll default it to primary. And now I'm just gonna, like I'm working with CSS modules or something, I have to think about, you know, I want to use class names, create a library by Jed Watson. I'm going to say here that I want to now include styles.
Keep Australia strong.
Exactly.
Yeah.
I'm going to plug in my variant now. And so that's what's cool about this whole map to styles concept is I've been able to create a little subset of styles that I can look up by key. And that makes it super easy to map through to React props. In this case, I'm just passing the variant down to this object. And so now when I jump over to my app, it's optional, of course, but now I've got the types coming through. I've got my variant prop I just wired up, and I've got primary and secondary. Again, the source of truth of that being in the style sheet itself. If I go to the style sheet and add another variant, it'll just flow through the types and everything. Again, even though it's purely static, which is like, we love that, the way we've got that balance working where, you know, you can actually define data structures in here. I think that was one of the biggest problems we found trying to get CSS modules to work the way we wanted, is you just have a single flat namespace, right, for your entire style sheet. So there was no way to create little subsections within the style sheet of like, this little bit is just for, you know, the variants, and this is the core style. And so there was a lot of like mapping code of having to, like, I would have to create the lookup, right, for in this case, the variant. I would have to create an object for like how to map between a variant prop name and one of the many classes in this style sheet.
Yeah, just any tool that doesn't give you sort of like escape hatches or any, just more power when you need it, even if like 99.5% of the time, you know, the flat normal way of doing it is fine. Like that last 0.5% can take you 30% of the time to figure out how to do it. That's really frustrating.
Yeah. And so like, obviously this is a very basic demo, but you can see there's a lot of power here in terms of like, I can export any data structure I want. The limitation with you have to think of the bridge here that we always talk about, the bridge between your static style sheet code that's static in the sense that it's eval at build time. And then this banner code runs in the user's browser, but this one does not. So that the limitation there is that whatever is exported here has to be can be expressed as JSON. So you can't have things like functions or whatever, but you can, anything that's a JSON is okay. So the next thing that I'm going to do is, I've got all these hard-coded colors everywhere. This is where the theming story starts to come in. What I'm going to do is create a new file here, and I'm going to call it theme.css.ts. And I'm going to, what am I going to do? I'm going to create a global theme from vanilla extract/CSS. So that's going to be my vars. So I'll export const vars equals create global theme. First arg is the selector, like we saw before. So I'm going to just chuck it on root. I'm not going to get too worried about different themes in this simple demo. Okay, so I can start putting my vars on here. I'm just going to call it dark blue is blue and light blue. This is not a good naming convention at all, but it's good for a demo. What else do I have? I've got my pink. Let's just call it pink. I can't be bothered naming things properly right now. So I've got my dark blue, my light blue, and my pink, and I could change those obviously. So now what I'm going to do is in my style sheet, I'm going to swap these out. So this one's going to be vars.dark blue, was it? Yeah. And this one's vars. Oh, actually I missed a step because this is in reality, this will probably be nested, right? It'd be like colors or something like that. Because that's the key point, right? Like unlike with CSS variables, we have to flatten everything out. Like I can create more complex data structures here, which is really nice. And already this is the beauty of it, right? TypeScript's already telling me like that's not a thing now. So it's like, okay, vars.colors.dark blue. Now it's happy. What was the foreground here? I think it was pink.colors.pink. Same here, vars.colors.light blue. Let's just copy paste. I'm getting lazy here. And I can use the var here. So I can interpolate values here as well. So I'm going to make that template literal. I'll swap that out for pink. It should all still be working. But if you look at the output now, you'll see that the secondary banner variant is using a var for the background and a var for the text color. And just like what we do with our classes, you can see that it's got a nice human readable like debug name, colors light blue, colors dark blue. It's used the path in the object as the key, like it knows you've got colors and light blue, and then also the hash at the end. So just like with classes in production, you just get the hashes, which is really nice. Pulls out all the stuff you don't need for the end user. And I mean, that's pretty much it as a basic demo. You can see like actually one other thing I wanted to show around the type safety. It's worth really hammering this point home. This is why we really like this approach of one, I just write the CSS variables by hand. Like this seems like over engineering, someone might say. The benefit of this approach, right, is like if I come along and let's say I just like delete one of my variables, I've got type errors right away. Like banner CSS/TS is saying like, where's pink gone? Like it doesn't exist on your thing, right? Let's pull that back. Okay, so that's good to know. Like in the world of design systems where I'm going to have consumers of these variables, it's really nice that they will get type errors if they're trying to access things we've removed. Maybe there's a breaking change. We've pulled some variables out, renamed them. They'll get the type errors. But there's more subtle benefits than that as well. Like JSDoc has deprecated comments that you can add to things. You can say like, don't use pink, please.
That's
right?
cool.
I've just deprecated the pink variable, right? So now when I come back over to my style sheet, I'm going to replay, like as an end user, I'm going to try and use a color, like pink is now crossed out and it's like, it's deprecated. Yeah. If I hover over it, it's like, please, don't use pink, please. It means that we have a lot more power as owners of a design system with our consumers. Yeah. We have a real a strong contract with them, and we can actually communicate with them in their editor like this as well with deprecations, which is really cool.
How many consumers do you have at your company, for example?
Oh, off the top of my head, I'm not sure. Do you know, Matt? A lot.
Yeah, it's in the 40s of apps. Yeah, it's like a lot.
Yeah, so enough that it's effectively impossible to tell anybody anything. So
yeah, well, because
mean,
we used to be in that world, right? With like the JavaScript versus TypeScript. You know, when we were in the JavaScript world, we had this problem where they had to meticulously read every release note and every migration guide, and if they missed anything, their app could break in a subtle way that they had no idea. Like, and that's for us that's what we talk about when we talk about scale, right? Is it's like that just doesn't make sense to work that way.
And that's why almost every CSS code base just sort of, I don't know, solidifies into this weird, I don't know, artifact of past poor decisions and whatever, past decision. We won't say they're poor necessarily. And people just like, I don't know if this is used anywhere, so we'll just add a new one, and on we go. And it just gets very weird and very big and very bulky and hard to iterate on.
Now, what I want to do is commit this. I'm just going to call it whip. And I'm going to push this up. So Matt's going to do something cool on top of this. I'll let him take the stage.
You're muted, by the way.
How's the size of that screen share? Is that all right? All right, so we're going to pull down Mark's code. This is the same repo he's just pushed to. And so you can see that we've got our banner component, and we've got everything he's just set up. We got type error. What's wrong? It's probably a caching thing. Did you commit the theme file, Mark?
What I did. Let me double check.
We need CI. So catch this.
I did not. It didn't get included.
Okay, cool. You can edit this part out.
Wait, are we going to keep
but
saying
Matt figured that out in like 3 seconds instead of, I don't know.
There you go. Push the fix.
Okay, cool. All right. So what we thought we'd show is something that vanilla can do that some of the other libraries maybe haven't thought about as much. And so because vanilla is just JavaScript, really, it's just JavaScript running, or TypeScript running at build time, it enables you to build abstractions that are still statically extractable. You don't need to, there's no AST magic happening to actually pull the code out of this application. It's all happening because the code is effectively running at build time. And so there's another team. I want to shout out to this team because there's another thing called the Stitches team, and they've set up their CSS and JS library that got released recently, and they sort of made famous this variance API that Mark's sort of been showing a little bit. So definitely shout out to them. So this is just an example of how that kind of API would work within vanilla. So right now Mark's got this idea. He's got sort of this root class, and he's got these variant classes. And so what if we instead, what we'll do is we'll call this old banner for now. And then we'll create a new banner. So banner. And we'll say, instead, we're going to use this create pattern API. So I've got here, I'm going to auto import that. It should say Stitches, it should say API. And so this is just like a pretend API. Imagine I decided that I wanted to create the abstraction that Mark's just created in the code with this variance. I've got primary and secondary. I want to group my styles like that. I want to sort of solidify that as a utility that we built. And maybe that's an NPM module, or maybe it's just something I'm using inside my application. And so at the top level, we could put our styles, the same styles as our base styles of our banner. But then we've got our variants that Mark created up here. So what we can do is we've got this, what we can call the variants API. So we've got our variants, and what different variants does this component have? It has a, so this is always get this wrong. So we have to name the variant. So we can have different variants. So think of the variants as different properties you might have to component. So this component has different variants, and one of those variants is a variance. It's a little bit confusing. You can call this whatever you want though. And so that variant has options of primary or secondary. And another interesting thing is that maybe you want your default variant for the variant type to be primary or secondary. So we want to default to primary. So sort of what we've done is we've created this idea of one set of styles that belong to a single node, but with one function. And so what we can do is we'll save that and we'll go into we've got our banner component. But now really all this banner component is just wiring up those styles. So what I could do, instead of this, we'll actually delete this. And instead we'll export const banner component. And we'll call in this other API, which I'm going to call Stitch as a little wink to the team because they've done they do awesome work and really just sort of showcasing what they've done. And so what we're going to do is wire up that pattern that we just created to this guy. So banner. All right. So if I start my app, take a minute to start. We can have a look and hopefully we should get the same result. We've got, that's interesting. I think we've flipped it around, have we?
I might still be setting the prop in app, or is that gone?
What was that?
Yeah, I'm setting the prop in app, see?
Oh, true, yeah. So Mark's overriding it to secondary, so we can actually delete that now and get rid of that. And we're going to flip back. So our default variant here on our component, which has just been mapped through from our actual CSS definition, is the primary, but I've still got my type safe API just like before, which is being generated from our pattern that we've created in our style. So what we've done here, what's interesting here is that we've created basically an abstraction on how we're building up our CSS. But this is all statically extracted and it's not part of vanilla. Vanilla doesn't understand what create pattern is. But because we're just giving you built-in execution of JavaScript, you can create abstractions like these. This is just one example. One thing we do in Gradle is we create a lot of atomic styles and then we map them to like a box component, which is something that's seen a lot in Tailwind style. That's something you can kind of automate and create like the same variant of how you create all your different styles. And so I just wanted to showcase this as like other libraries, especially ones that are trying to attempt static abstraction, they maybe can't build these kinds of abstractions on top of their system. They're always mostly limited to what they can do, what they can understand at an AST level, whereas we can sort of create whatever you want, as long as you can forward it over that static bridge, which is what you're sort of seeing here. You still have that. This is just mapping basically this set of styles and this object through to an actual React component, but it could map to anything. It can map to a function or whatever you want. So yeah, I just wanted to showcase that. That's kind of the demo.
That's cool. Yeah, I love that sort of scaling up of abstractions. The simple setup is, very straightforward if you've done CSS modules, CSS and JS. Yeah, I love it. Cool. So another question, maybe, is people, using CSS modules or CSS and JS, or just want to try this, or anyways, you have a project like, or you want to start a new one, is it ready to go for something? Like, should you start porting stuff? Should you start new stuff? Like, what's kind of the status of things? And so.
So in the README right now, it does say that it's an alpha, but to be honest, it's sort of like we're almost just saying that just to cover ourselves a little bit because of the fact that we're not running it in production yet.
Yeah.
So it felt a little bit like not quite the right thing to present it as this finished, polished thing when we're not in production yet. That said, what I would say is it's not far off being production ready. Like we're actively looking to roll it out to production very soon. It is based off Treat, so it's inherited a lot of the battle testing that Treat had as well. So there's that to factor in. So I think what I would say is if you're looking at it and you're interested in using it, the safest thing is to wait, maybe wait till we're in prod before you go into prod if you really want to play it safe. But if you try and it works for you, then it's probably fine as well. So it's really up to you. Like, what's your tolerance for something being a bit bleeding edge? I think it's safe. Personally, I would use it in production today personally. But but I'm probably a bit biased to say that I'm working on the thing.
Yeah.
Yeah. Like it's not gonna do anything too unexpected. You might trip over the odd minor thing, like any bleeding edge software, but it's pretty good.
We're kind of looking to roll it through Braid, which is like a big step for us, which is very much us saying it's production ready. I'd hope sort of within a month's time. So like that's a timeline if anyone's interested.
Yeah, awesome. Yeah, and if you're using another system, is there any automated, semi-automated way of porting stuff? Is there some sort of, I'm just kind of curious because there's a lot of CSS modules out there. So wonder if that's something you thought about.
Well, the beauty of our model is because from a compile target perspective, it's basically the same as CSS modules. So you can do them hand in hand. So what's good is that because there's no runtime costs and there's no, outside of just learning the API, there's no like cost really. You can slowly migrate an application if you want. You can use parts of the features if you want. You can have parts of your systems use CSS modules, and you can do that partial migration, which I think is really, I think TypeScript really nailed that when it came out, like the partial migration. And yeah, I think you're sort of in a similar boat here. You don't have to migrate everything straight away, but they should work hand in hand. If you're using a tool like Webpack, it will compile those styles exactly the same way as if you had imported them as a LESS file or a CSS file, as if you imported a vanilla file.
Cool. Well, it's been really wonderful having you here. Vanilla Extract is really exciting. One of the cooler things I've seen in a while in the CSS land. Yeah, I guess any closing thoughts before we stop?
One thing we didn't really touch on is that our philosophy is actually, despite everything we've shown you, our philosophy is like in the work that we do is actually we want to write as little CSS as we can. So that factors into our API decision making as well. Like so in our design system, we have a box component, which is where most of our shared styles go. And you can kind of think of that as being like it's a wrapper around a bunch of utility classes, like a Tailwind type setup that we've hand rolled that. And that's why we're betting so hard on static CSS. Because I think at first glance, if you don't know that, if you don't think about the world that way, you might look at the work we're doing and say, that seems a lot more limited. Like with runtime CSS, I can, based on a prop, flip out, responsive styles and do all sorts of like really complex things that you just can't easily do in a static style sheet, right? The way we deal with that is we say, well, like most of our styles are operating on the same set of core utilities. And if we wire that up to a low-level box component, that it provides the dynamic, like effectively that's our runtime CSS, right? Like, because I can at runtime pass different props to this component, including responsive props, right? I can say on mobile, the padding is this, and on desktop, the padding is that. I can make all of that driven based off props of another component on top of that. And so that almost becomes your runtime CSS layer is your components. So what we want to do is make it so that we're trying to make a CSS library that's designed for that world where like we just want you to wire this up to a component and use components as much as possible, and don't get caught up on trying to bring all of CSS into your runtime to solve that problem. We think components are most of the time, components are the better solution to that problem. Yeah.
I'm curious too, if you think like SSR, the constraint of SSR is part of why you think this way. Because I remember when I first started doing React, like I just started using, straight styles for everything. And I was using like windows.match media and, inner width and stuff like that just to adjust things. But then I had this is like 2014, and I started prototyping something with like SSR, and all that broke. And I spent a while trying to work around it. And then I was like, oh, okay, that's not working. And then, then it was back to media queries and all that jazz. Yeah, do you think that's part of the sort of why you think this way? Because you're just building like a SaaS app.
Yeah, I think it's definitely the SSR angle. I think also this style of approach comes from building a design system. And as a design system with many consumers, we don't want to push this runtime cost that we don't actually need onto consumers. Like if a consumer decides they have to have emotion or whatever, like fine, like you can use that on top of this system. But ultimately as a design system, we want to give something as cheap to run as possible, because these are very low level, very high use components. And so any sort of If we don't feel like we need the runtime, why would we ship it? Obviously, you can still choose to add it, but yeah.
Yeah, it's like system software versus app software. You got to be very cognizant of you're under everything else, so you want to be as little as possible and as simple as possible, and also it's like predictable as possible too. But if you like define everything up front and you don't allow the sort of like, yeah, just like pass in a number and we'll do something to it, it might work, sort of thing like that adds a lot of possible failure cases, where more predefined stuff kind of limits.
Yeah, a lot of on that point, like a lot of our work was very inspired by our early work with Braid around the box component, particularly was inspired by styled system. Because they, I think they've, at least from what I saw, like they were pioneering this idea of trying to get these low level design primitives in your system that are, rather than writing style sheets, you use components. And I was a big fan of that idea. And I think for me, that was like part of the light bulb moment was like, well, if I'm drawing from a predefined palette, what do I need a runtime for? They would use the runtime for, like, as you're saying, for falling back to values that aren't in the palette. But in some ways, like, I actually didn't like that feature. That was one thing I didn't like about it was, they would like, so that, for example, you'd have a padding prop on box and you'd pass it a number, which was like an index in the array of like your scale of padding. So you'd say padding of 1 is actually just like one of your elements in your array, not 1 pixel. The problem was if you went padding of 1, 2, 3, 4, 5, let's say, and you've gone one step beyond the length of your palette,
right?
You've suddenly gone, you've suddenly gone from like 48 pixels of padding or whatever to 5 pixels of padding. And you and you're not getting any like type errors or anything. Like your editor is like looks good, and your app just looks terrible. And you're like, what happened? And I would say, like, to me, that was almost where, like, I was like, well, not only do I kind of not feel like I don't need the runtime, I actually think it's like a better dev experience to more clearly mark, like, here are the guardrails around what the system provides. If you want to write a custom style sheet with 5 pixels of padding, and that is actually what you want to do, then go for it. But it's not something that we just sort of do. Like it's almost like failing silently in my mind, in a way. It's like you most of the time I found I didn't want that behavior. So I think with the work we're doing, it's like we're trying to strike that balance between the power of something like styled system, but keeping it static so there's no real cost to it. But with vanilla extract, and particularly with the variables being part of our public API now that we can expose to our consumers, it's like you can create custom styles if you want in your app. You could even do, to Matt's point, you can even do it at runtime in something like Emotion if you want to as well, like that. You're not blocked off from doing that. But as a library, like, we keep it guardrailed in a good way. We keep it static, keep it lightweight.
Yeah. And talking about style systems, also, style systems, like you're saying, it's a beautiful abstraction, but you don't always need that abstraction. It's like, and what I like about vanilla extract and CSS, well, I mean, especially about vanilla extract, is that you start super simple. You're like, I need background red, and that's it. You can literally have just one style, but you can scale up, as far as you need to, create whatever abstraction on top of it you want. So and that's a nice feature, is that, like, I've used style systems and theme UI. It's sort of child project, and really liked it. But when I'm just mucking around with something, it definitely feels like too much. It just feels like a lot of overhead to get started. So yeah, that's a nice property of what y'all do. Well, cool. This has been super fun. So thanks for making the time and joining me on Zoom. And have a great day. Talk to you guys later.
Awesome.
Bye.
Thanks.
Thanks for having us.